are called fundamental quantity. So example, just now we said example, mass,
length, time,
yes, very good.
temperature,
Temperature,
current.
And mole, amount of substance.
Yeah, amount of substance.
And last one, luminous intensity. Candela. These are fundamental quantities. So, so remember like this, whenever fundamental quantity comes, it means what? It is a basic quantity. Whenever you see fundamental, it is basic. Now next is derived quantity. So there are so many derived quantities. Other than this, all are derived quantity. We can say like that. So can someone make a definition of this one?
The quantities which are derived from the fundamental quantities are known as derived quantities.
Exactly. And if I want in similar manner, which I wrote above,
those which depend on other physical.
exactly. The quantity which depends on other physical quantity. Come on, write in your own words and write some example. Okay, I want example from everyone, one by one. One example from each. Okay, let's start with Garima.
Density.
Density, yes. Write one example as density next. Maz Mohammed Khan. Maz, one example. No? Shadab?
Yes, sir. Acceleration.
Acceleration, yes. Write acceleration also. Okay, and from Rajshekhar's. Who's there from Rajshekhar's phone? Like, who's this? Who's the name?
Sir, is my daughter actually.
Oh, okay, okay, yeah.
She is listening, but actually, the first day, na, that's why she just go through now.
Okay, no problem. This is the first class for 11th standard. Today,
Yes.
Today only we are starting.
Okay.
Okay, what's her name?
Punyaja.
Okay, give me one example of this derived quantity.
I have to recollect.
Actually, I have started the class from right now, so
No
I
problem.
haven't studied yet.
No, other than this quantity which we wrote for fundamental, those are derived quantity. As they all gave examples, right? Garima said like I think so. Okay, let's write example. The quantity which depends on other physical quantities. Derived quantities. Speed, acceleration,
Sir, force can be also
yeah,
like
force. Yes, yes. Other than this, all are derived. We are deriving from basic quantity. That's why they are called derived. Force, etc. That's not right. Oh,
Are there only two types of quantity?
yeah. There are only two types. One is fundamental and one is derived. So by this, can we make a common definition or common terms or a common word? What we wrote? They are physical quantity. Now, what are physical quantity? Can you make this common term like a derived and fundamental? From this, we are writing one
the
common term.
combination of all the fundamental and derived quantities are called physical quantities.
Exactly. Means they are directly depend or indirectly. We can measure directly or indirectly. See, here we are directly measuring. Mass means directly measuring. But force, we are not directly measuring. We are indirectly measuring. Right? With the help of mass, time, length, all with the help of all these three, we are measuring force. Current, we are directly measuring. Right? Temperature, we are directly measuring. But if you want to measure speed, we are not actually directly measuring. We have speedometer, yes, but actually we are not directly measuring. We are measuring with the help of length and time. That means we are how much distance covered and in how much time. So indirectly measuring. So physical quantity all the quantities in terms of which laws of physics are described and which can be measured directly or indirectly are called physical quantity. See, if you want example, all example is valid for your mass also valid and speed also valid. Both examples are valid for physical quantity. You can write mass, length, speed, force, etc., time, whatever. Done?
Yes, sir.
Shall I scroll?
Yes.
So
Yes,
you
sir.
understood this quantity, physical quantity, all two parts, two types.
Yes.
Everyone, Garima,
Yes, sir.
mass.
Yes, sir.
Okay. Fine. Now units. Okay. What is unit and why do we need unit? Okay, first tell me why do we need unit? Unit, what is unit? We already discussed. Now, why do we need unit?
Sir, to express the physical or chemical properties of an element, element I am saying, a quantity.
Quantity, yes. Or to compare, right? If my height is 6.1 and my weight is 75, but how will I say that this is my height and this is my weight? This is my height and this is my weight. And if I assume that your height is 5.6 and your weight is 65, if I want to compare our height and our weight, so can I compare cross here this way? Can I compare 6.1 to 6.5?
No, sir, you cannot do it.
I cannot. So how can I compare? It should be 6.1 feet and 75 kg. So this makes a meaning to this number. I'll say 1,000, 10,000 paise and 10,000 rupees. Right? This makes a meaning to this 10,000. So rupees and paise are the units for currency. Right? If I say I'll give you 10,000 rupees, it means something. If I say I'll give you 10,000 paise, means you need to divide by 100, means I'll give you 100 rupees only. Right? So unit gives a meaning to the number. So the unit is important. So it gives a comparison, so many things. Without this unit, there is nothing. Okay, so how to choose unit? First one. Choice of unit. This is something important. Suitable to use. Second one. Accurately defined. What do you mean by accurately defined? So that everyone can understand. Okay, if I say just now I wrote example 6.1. I just said 6.1 and I was talking about feet, but I didn't write here. So and you will assume that it's meter. So you'll think 6.1 meter height means it's so much, right? So that means that for understanding, I have to write here something, feet. That is your accuracy or defining properly, the number which is defined properly. It should be easily reproducible. It should not change with you guys still can hear me, right? Properly?
Yes, sir.
Because here I think so my system is lagging. Superb. You should not change with change in physical condition. Condition. What is the physical condition means?
The temperature, pressure, etc.
Yes. Temperature, pressure, or moisture, etc. So till now we discussed some 6 quantities, 6, 7, 8 quantities that will change with temperature, pressure, or a moisture. Will distance unit will be meter, instead of meter it will convert to seconds if I apply temperature or pressure? No, right? That means we have applied a proper units. Actually, we are studying, we know this because we are studying since 7th standard or 6th standard, the units, length and distance and all that. 6th standard we are studying. So we know that. And the last one is universally acceptable. Shall I scroll?
Yes, sir.
Is anyone writing?
Yes, sir. Then, sir.
Okay, done, right? Fundamental or base unit. Again we came this word. Again this word came. Fundamental. What do you mean by fundamental again?
The basic quantity.
Basic. It is independent. Right? So here we need units. That was quantity. So unit of those quantity will be fundamental unit. Unit of fundamental quantity will be fundamental unit. Simple. Right? So what was the first one?
Mass.
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 So unit of mass will be
Meters. Sorry, kgs.
किलोग्राम मीटर है क्या रे बाबा
सर वो हाँ, recording में बोल दे.
अच्छा assume we went to rice shop I want 5 meter of rice I want 5 meters of rice next what was the next
Length,
It is length,
unit of length will be
meter,
meters.
yes third one was
time,
time unit
seconds,
Seconds.
seconds here we have other units also but those are not base unit base unit is meter same goes for kilogram base unit is kilogram then let's not try to this etc now next is derived units can you give some units for this
Sir, Newton for force, meter per second square for acceleration.
what was the first one what we wrote for
Newton for force,
Newton for force yes and here we wrote speed so unit of speed will be
Meters per second.
exactly meter per second for speed then what was next acceleration
acceleration, meter per second square.
Meter per second squared.
then force
Newtons.
Newton or kilogram meter per second square okay so any doubt till now derived quantity derived unit fundamental quantity fundamental units
no, sir.
No, sir.
everyone okay and again I forgot your name dear from Raj Sekhar's iPhone please change your name and come okay next time let me allow here now itself you can change your name I have already allowed I think so.
Okay, we change the name. We will change the name.
Yeah. So that I can call her, right? So that
Okay.
because I want interactive class.
Okay.
Sir, I have a question.
Yeah. Ask.
In the choice of unit,
Yeah.
in the third criteria, you said it should be easily reproducible. What does
Yeah.
this mean?
Means like easily reproducible. Just now we gave example for this meter, right? Meter was a unit for length. Easily we
Yes.
are reproducing. We are getting this easily, all these units. And same way, see, generally we won't say length as a kilometer, not as a centimeter. Easily we will say first it will come in our mind that is meter. Same way for mass, it will come for our mind that is kilogram. No, we have centigrams also, we have milligrams also, we have micrograms also, right? We have 1 ton also. We are not using that. We are generally standard we are using as 1 kilogram. So we are easily reproducing.
Yes, sir, got it.
Okay.
Sir, will we not be doing the first chapter?
This is a first chapter here.
I mean, according to the NCRT.
According to NCRT, it's units and measurement.
So
We'll
in the
study-
second chapter, units and measurements.
Okay, physical quantity you mean to say, right?
Physical world.
Okay, yeah. That also we are going to do.
Okay, I was just clear.
Yeah. That I want to do with like modern physics.
Okay, sir.
We have modern physics also. It's very, very important. Like almost 2 questions are coming from the modern physics. Okay. So system of units. Okay. So system of units, in that like we have actually 3 systems. See, our European countries were using FPS, foot, pound, second. And other countries were using MKS.
Sir, I think FPS is only used in United Kingdom,
Yeah,
and MKS was used in the whole of Europe, and CGS was
European
used
cities.
maximum in all of the world.
Exactly. And CGS like it's a smaller system, Gaussian system. So they
Yeah.
were like especially they were used by British engineers, FPS. Even like we were also using those initially, but then we converted to MKS actually in India. So like see, whenever we are sharing a data, it should be like minimum and best quality, best data. Means like we should give maximum values and in short. So while writing every time units, it makes some space. It requires some space. So and every country has a different unit system. So what they did, they just made a standard unit system that is SI unit. That is similar to MKS. So they made one standard accepted by every country. So what they will do, they'll give data and in below they'll write in SI units. So then everything is done in one shot. So they made this way. So first one, foot. Pound. Second. Second one, meter,
Kilogram and seconds.
kilogram, seconds. So if you observe, the first one is for length. So tell me for CGS.
Centimeter, gram, and second.
Exactly. Centimeter, gram,
And seconds.
seconds. And SI is International Standard System. International,
The SI is same as MKS, right?
exactly.
Yeah.
Standard System. Okay. So this F here M and here C. This is for length. This pound K and G. It is for mass. Here S.
Yeah, the seconds was maintained for all over the world, right? There is nothing other than seconds.
Yeah, there is nothing in seconds. Seconds, milliseconds, microseconds. There is no derivative of seconds. Okay.
Yes.
At least that's good. So we don't have to remember for seconds. Okay. SI unit is same as MKS. Done?
Yes, sir.
Yes.
Okay. Let's go for next. So let's write some base quantity. Mass. It is kilogram. Then length. You can write with me fast. Meter. Time. Seconds. Current.
Amperes.
Ampere.
It's candela.
Exactly. Luminous intensity. Candela. CD. Candela. And last one, amount of substance is
Moles.
exactly
Sir, you
moles.
left temperature.
Which one? 1, 2, 3,
Temperature, sir.
5, 6. Oh, temperature. Temperature.
Sir,
Kelvin.
is it Kelvin, right, sir?
Yes. Now let's write some information about this each. Okay, let me ask you some questions then. Do we have time? Yes. Do you know, like, before asking questions, do you know this conversion, right? Do everyone know unit conversion?
Yes. Sir.
I mean to say, like, exa, pico, tera, giga, mega, kilo, all this.
Yes, sir. Till mega and giga. Not
Okay, then let me give you
but,
here because it will be
after to the power 12, it's not actually
required.
required.
Yeah, we will just study up till 10 to the power 12 only. Okay, so let's write this way. Prefix power of 10 and symbol. Okay, then let's start with a deca in between. Power 10 to power 1 and symbol is dA. If we go above deca, we have
Hecto.
hectometer.
Power 2.
Yes. Power 10 to power 2. Symbol H. Then above that we have 3. That means kilo. 10 to power 3. Symbol small k. Above that we have mega.
Mega. Small.
10 to
But,
power
it's 6.
6. And capital M.
Giga is 9.
Yeah. If we
F
go
is
above
0.
it is giga, we have 9. It's capital G, gigabyte, terabyte,
Yes.
10 to power 12. It is
Tera.
now below -1 means deci,
Deci.
which is denoted by small d. Second centi,
Centi is
centimeter,
-2 divided by cm.
small c. Cm means centimeter.
Yeah.
-3, so which is milli, which is denoted by small m. This is micro for -6, denoted by mu. And then -9, nano, nanoparticles. Which is denoted by small m. After that, it's not required, but still, let's write one more. -12, which is, anybody know this?
Is it pico?
P. Denoted by P. Actually, in one exam, they asked femto also, which is -15. That was rarely asked.
And the zepto is -18.
Atto. F. After that, it's not required actually. This is also enough, more than enough.
Sir, what is the one? -15.
Femto, F-E-M-T-O.
Okay.
Okay, some other units also will write. What are other units? Like astronomical unit, right? Yeah, once you're done, tell me. I'll scroll.
Done, sir.
Everyone? All 5 of you?
Yes, sir, that's done.
Yes, sir.
Some special type of units, like they're called macrocosmic unit. So actually, if I give you in simpler words, for large distance, not long. Long is wrong word. Larger. Large distance. First comes here astronomical unit. No, what is astronomical unit? Have you heard this?
Yes, sir. To measure the radius or the distance between any two celestial bodies.
Yes, astronomical units. But how they got one astronomical unit? How they found? By average distance. The average distance of the center of sun from center of earth. It is not exactly, it's average, approximate. So 1 AU is equals to 1 point, let's make it round off, 1.5 into 10 to power meter. B light years. Have you heard this term, light year?
Yes.
Yes.
Very good. So can you guess what it will be? Name by the name. See, always
Yeah, it will be the distance covered by light in a year.
exactly. Always there is an answer in name itself or question itself. Always try to find answer in your question. It will be hidden there. The distance traveled by the light in 1 year. So 1 LY light year equals to 9.46 into 10 to power 15 meter. Parsec. Have you heard this parsec? It's smaller than that. It's smaller than AU. Right? Let's write this. One parsec is the distance at which arc 1 AU long. An arc 1 AU long subtends an angle of 1 second. So 1 parsec equals to 3.1 into 10 to power 16 meter.
Sir, can you explain this one more?
See, 1 parsec is the distance at which an arc 1 AU long. What is 1 AU? 1.5 10 to the power 11 meter long. 10 subtend an angle of 1 second. Means in 1 second, this much arc it will cover. That is 1 parsec. Arc is 1.5 10 to the power 11 meter long. That is 1 parsec. So therefore, 1 parsec equals to 3.1 in 10 to the power 16 meter. Understood?
Yes, sir.
Okay. See, next class I think so tomorrow, right? So we'll have some small quiz on this. Like I'll ask the things which I will discuss only. So don't you worry. Then we'll see dimension analysis. Yeah. Okay, guys. So see you tomorrow. Any doubts till now,
No, sir. No doubt, sir.
everyone?
Thank you, sir.
No doubt.
No doubt? Okay. Okay, guys. Bye-bye.
Thank you.
Yeah, bye-bye.